All right. So hello, everyone. My name is Andrew Crumpley. I am currently finishing up my master's degree here at Utah State University, and I'm excited to share with you today the work that I'm doing with commercial cheese slices. Um, so before I jump too far into it, I just want to give a quick um, just overview of some of the other accomplishments I've had outside of data collection and analysis. So as part of my project, I've developed two novel methods for measuring cheese slice stickiness using a texture analyzer. That's been a lot of fun trying to figure that out. And I have had a publication accepted in JDS Communications, specifically diving deeper into one of those methods. I've also presented my work for Build Dairy twice before now. And I've also presented my research at ADSA at their annual conference last year, and then at the ADPI Ingredients Summit earlier this year. And I've also been accepted to present my work at the ADSA annual conference this summer. And then probably one of the things I'm most excited about, I am very excited to start work with Idaho Milk Products here in a few weeks at the beginning of May. So excited to start contributing to the dairy industry in other ways. Um, so just to give a quick overview of what we'll be talking about, I'll give a brief introduction of my project and some of the hypothesis and objectives that we're working on. And then we'll dive into what we've run and what we're seeing from the data that we've collected so far. And then I'll give just a brief kind of continuing work, what to expect as we kind of power through to the end to try and get this research finished. So my research is based around one specific defect with sliced cheese, and that is that it likes to stick to itself, which reduces consumer convenience and kind of defeats the whole purpose of why we slice the cheese in the first place. And really, the big question we're trying to answer is why does this happen? Because as much as we think we know about cheese, we really don't know this. We don't know why cheese is sticky. And so really the goal of this research is to identify the factors that contribute to that stickiness so that further research can be done later on to see if we can help to prevent some of that sticky behavior. So our hypothesis is that the stickiness of these cheese slices comes from a couple of places. The first thing we're looking at is intrinsic properties. We're thinking about the composition of the cheese, and we're looking at some of the material properties. For instance, one of the properties that we test for is tensile strength, how well the cheese can stand up to being pulled before it breaks. Um, and then we're also looking at some external factors like the packaging material. We're looking specifically, we're interested in the paper pieces that are put between cheese slices. We're interested in seeing how exactly those are affecting cheese stickiness. We're also looking at gas composition of within these packages. And we're looking at a few different mixtures of nitrogen and CO2 within my research just to see how those gases may be affecting our cheese. And then I've done a little bit of work previously looking at temperature fluctuations during storage and how those may affect cheese stickiness as well. Um, and really, our main hypothesis is that all of these may be contributing to the stickiness of the cheese, which is why we're testing for them. So our objectives are first to develop baseline data of commercial cheese slice stickiness. And to do this, we've obtained from local retailers 29 different samples of cheese from various producers. We have several different varieties. And we're just looking at we're measuring, as we'll come up here to see in a minute, we're looking at things like the composition. We're measuring how sticky these cheeses are. We're looking at some of those material properties just to get an idea of what's currently happening in the cheese. And then our second objective is looking more deeply and more specifically at the gas composition within these packages. So as I said, we have those different mixtures of CO2 and nitrogen that we're looking at, and we will be measuring the stickiness of these cheeses across 5 time points, and just taking a look at what some of the changes are, if any, that are occurring over time. So the data that I'm going to be sharing with you today is all coming from Objective 1. Um, Before we dive too deep into it, I do want to just make it clear that what I'm sharing with you today is very preliminary. We're still working on finishing data analysis on Objective 1 data. And so what I'm showing today is not all of the data that we've obtained. It's just what we have had more thoroughly analyzed and are more comfortable sharing with you today. So we're hoping to be able to share a lot more of that in upcoming presentations. But to move on to methods, as I said, we did some basic cheese composition on the samples that we're running. And we're also looking at the gas composition within the packages, and we are trying to measure the proteolysis of these samples, trying to see if maybe there's something to do specifically with the protein and the types of protein we have in there that could be affecting that stickiness. We're also measuring, of course, the stickiness of these slices using a few different methods. The first one we're doing is a peel strength method, which is one that I have not presented on previously. Just to give a real brief explanation of how that works, we put the cheese into the texture analyzer as shown in this photo, and that probe will lift the top cheese slice off and it measures the force required to do that. And when we do that, we get a graph, a series of curves that looks something like what you see pictured. And then we're able to make some determinations there as far as the force required to peel cheese slices off of each other. And then the other method that we're doing is a sensory method. What we're using is a 7-point sensory score that was developed with assistance from Mariam Baniasadi in Tillamook. We're very grateful for her help and expertise in developing that. And so those are what we're using to measure the stickiness of these cheeses. And finally, we're also measuring some physical properties. As I mentioned before, we're doing a test that measures the tensile strength, how strong the cheese is in terms of when it's being pulled apart, how much force does that require? And as part of that measurement, we're also measuring the thickness of these cheese slices. And then finally, we are also measuring surface energy, which is simply put, a measurement of the forces at the surface that are present due to different chemical groups. We're measuring things like hydrogen bonding, the energy associated with that. We're looking at the energy associated with dispersion forces that could all be affecting the stickiness of these cheeses. Surface energy is measured by measuring the contact angle of different solvents on a surface. And these are being run for us by Dr. Shyam Sablani and his lab up at Washington State University, and we are very grateful for their help as well. So I've kind of thrown a lot at you, but basically we're measuring the stickiness of our cheese. We're measuring some different physical properties and composition of these cheeses. And then we're trying to determine, are any of these affecting the stickiness that we're measuring? And so what we have here is first, with these initial samples that we have our composition. And then this is just kind of the overall correlation that we're seeing. The deeper reds, the darker greens, those are higher correlation. We like those generally, as long as they're meaningful. Some of the lighter colors, it means there's not really a whole lot of anything there. We're going to be looking specifically at the things that I have highlighted here. So we're interested in some correlations we're seeing with the percent of carbon dioxide within packaging that we're measuring, and then also some correlation that we're seeing with the thickness of the slices that we're measuring. So we'll start with the thickness of slices. The slice thickness is somewhat correlated with sensory experience. And if we think about it, that makes a lot of sense. There's when we're talking about a sensory experience, we're talking about more than just the force required to separate two slices. We're experiencing all kinds of different things in a sensory experience. And so what we see here is that as the sensory experience score goes up, a higher score indicates an easier peeling. We see the slices are getting thicker along with that. And so this makes sense because thicker slices are going to be less delicate And so as we're peeling those off of a stack, it's just going to make it feel easier to peel because we're not so worried about it coming apart and breaking and splitting. And so that sensory experience changes even if the actual stickiness doesn't. And then we also have seen some interesting correlations with carbon dioxide and cheese slice stickiness. So what we have pictured here is a correlation with carbon dioxide and then both of the measurements that we get from our TAC testing and the measurements that we're getting from our peel testing. And what we see here is that as the amount of carbon dioxide in a package of cheese increases, we see a corresponding increase in stickiness of our cheeses. And after thinking about it for a little bit and trying to figure out, what's going on, what we hypothesize is that we know that CO2 is soluble in cheese. It's soluble in water. Water is definitely present in cheese. And so as CO2 absorbs at the surface of a cheese slice, it may decrease the local pH and solubilize calcium locally, making the surface of that cheese slice just a little bit softer, which means we wouldn't necessarily see a corresponding drop in pH, which we haven't, of the overall pH of the cheese, but just there at that surface, it may be enough to soften that surface and make it just a little bit more likely to stick. And so just to give some overall conclusions, it's looking like the gas composition within packaging may be having an effect on stickiness behavior in our slices. And it definitely appears that the thickness of these cheese slices can affect our sensory perception of stickiness, even though it's likely not having an appreciable effect on the actual sticky behavior of those cheese slices. So just to give you a quick glimpse into what's coming, we're working on completing the data analysis for Objective 1. We have at this point collected all of that data, and we're just trying to go through it with a fine-tooth comb and really get a good understanding of what's happening. And then we are also working on data collection and analysis for Objective 2. So as I mentioned previously, we have 5 time points that we're measuring. As of today, we have processed our 4th time point. So here in a couple of weeks, we'll be doing that final time point, and we will be working on completing the last bit of that data collection. And then it's just going to be a lot of data analysis just to figure out what the patterns are, what's happening. And we're hoping to be able to present a lot of that data at the annual conference here in a month. So just a big thank you to Build Dairy for, of course, funding this work and organizing everything, and a big thank you to Tillamook as well for their help. This work would not have happened without a whole lab to work on it together, and so I'm grateful to them for their help. And then, as I've mentioned already, a big thank you to Miriam Baniasati and to Dr. Sablani at USU for their assistance in this project as well. And with that, I'll take any questions.
Okay, do we have any questions?
Yeah, I'll ask a question.
Okay.
Andrew, if you just had to make your best guess, I know you're looking at a lot of different variables and considering everything. If you had a guess at this point, what do you think is the biggest reason that it causes the stickiness and the tear?
If
just your hunch, if your best guess, yeah.
Sure. So if I had to make a guess, there would be a couple of things. I know that there's stuff that's happening on the industry level before it gets to a consumer. I don't have a good guess there. As far as what consumers are experiencing when they're experiencing some really sticky cheese that doesn't want to come apart from itself, there is a very good indication that temperature abuse is going to increase that stickiness very appreciably. And so if consumers are picking up cheese at their local supermarket and then it's not getting put in the refrigerator pretty soon after that, if it's out for a little while as they're making their trips and they're going home and they're putting things away, if it's able to warm up a lot there and before it gets put into the fridge, that is going to create a massive increase in
So
that
is that,
stickiness.
I know you were looking at temperature or storage conditions. So is that something you're manipulating a variable for in your studies, that you're going to basically temperature abuse, like refrigerate ambient temperature, refrigerate ambient, and just see if that is increasing the issue?
So that's not a specific part of the thesis research that I've been doing.
Uh-huh.
That was something that we did in some of our
Okay,
um
cool.
our method development. And so we have done some of that already just as far as developing the method. But yeah, as far as the specific thesis research, that was not included
Yeah.
in the thesis
So when you
research.
did it in your methods development, that's what you were seeing, that increase the stickiness, or the, I don't know what you call it. Yeah, stickiness, if that's the right word. The lack
Yeah,
of
yeah,
ability to peel apart.
yeah. No, it definitely yeah, it definitely seems to increase the stickiness, that primary stickiness when you're
Yeah,
pulling it off.
correct.
As far as the effects it has on the behavior after that, if you're trying to put it back together, it doesn't seem to affect the stickiness after the
Yeah,
fact, but that initial peel certainly seems to
right.
be.
And that's the consumer concern, right? It's not like,
Yeah,
oh, I really want to be putting it back after I pulled
yeah,
it apart.
yeah,
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 cool. Well, I
absolutely.
appreciate it. I mean, it's, your research has been something that I'm excited to get the final conclusions about.
Perfect. Well, thank you so much.
Yeah.
I have a question. I'm Willie Bachman, I'm a dairy farmer, so I'm not a researcher by any means. Just curious now, have there been things sprayed onto the different slices to cause them to not stick together? Maybe cornstarch or something similar to that, that would something that's a food, type of thing that you could use that would not be affecting the taste or flavor and all that stuff, but yet make it not stick.
Yeah, yeah, great question, Willie. I know that that is done a lot with shreds. Um, but as far as what I'm seeing when I pick up cheese at the store, what I'm hearing from our industry partners, I don't believe that's a common practice right now to have an anti-caking agent in slices. Um, Really, the most you're going to see with slices right now, if anything, is that they're going to be putting those pieces of paper in between their slices. Um, and that has been included in our research. We are looking at the effects that that can have. Um, but yeah, as far as I have heard and as far as I've seen, we're not really seeing any kind of anti-caking agent that's been used on slices specifically.
Maybe a paper made out of cheese.
Hey, there you go.
There you go. Made out of cheese.
Okay, I don't see any other
Hey, Kim.
questions.
Hey, Kim, can I ask you a
Oh,
question?
yes. Sorry, go ahead.
Hey, Youngsu Lee from Washington State University. It was a very interesting presentation. So it looks like if you are tackling stickiness of sliced cheese and surface analysis is important. So do you have any other suggestion or plan to analyze the surface properties or composition other than contact angle measurement?
Um, as of right now, no. We're really just as far as the scope of this research, we're just really interested in the surface energy
Hmm.
um, component. So yeah, we're really right now just measuring that contact angle to calculate the surface energy, and that's about the only specifically related to the surface thing that we're doing right now.
Okay, all right. Thank you.
Yeah, thank you.
Okay,
Hey, Kim, Andrew, can you hear me?
Yeah, Eric, what's up?
So, just want to congratulate you on landing a job out in the industry, because that's what our program is all about, getting you through some training and then getting you landed into a role. So, hope you make lots of money, and hope you have a wonderful time working in the dairy industry in the future. And that's an encouragement to all the rest of our students as well, that it definitely happens and can be done.